Hello and welcome to Diplomatic Derivatives. In this series of lecture, we're talking about applied mathematics. In our previous videos, we discussed scalar product of vectors as well as cross product of vectors. So first check those videos out before moving on to the next topic, which is scalar triple product. The link is in the description box below or the I button above. Now we talk about the scalar triple product. So what is the scalar triple product? The scalar triple product of three vectors a and b is. Now, first of all, we talked about in the previous video about the cross product of vectors, where we said that the magnitude of the cross product of vectors of two vectors that lie on the same plane is the area of a parallelogram, okay, which was basically magnitude of a cross b, okay, magnitude of vector a cross vector b. Okay, this was the area of a parallelogram, right? Now when we talk about scalar triple product, it's basically the area of a parallelepiped. Parallelepiped is a 3D of a parallelogram. Okay, so in parallelogram we have x-axis and y-axis. In a parallelepiped we will also have the z-axis because we're talking about a 3D figure. Okay, and what is the formula for this? It's basically a dot b cross c. Okay, make sure to draw the vector signs here. It's vector a dot vector b cross vector c. Now by looking at this formula, you can easily understand what is the resultant, like what is the type of resultant that we're going to achieve. So first you're going to solve the bracket, which is b cross c. Once you do b cross c, the quantity that you're going to get is going to be a vector. Okay, because a cross product yields a vector. After getting that vector, you will do a dot product of that vector with vector a. So once you do the dot product, the resultant is a scalar. Okay, this means that scalar triple product is going to give us the answer as a scalar quantity. Okay, so by triple product means we are going to have three vectors and hence it's going to be in 3D. Okay, so we're going to have a area of a parallelepiped that is going to be coming from this formula. Okay, so b cross c, first you do the cross product, you get a vector, then that vector with vector a you do the dot product, and that answer is going to be a scalar quantity, which is basically the area of the parallelepiped. Okay, now in components form, since in the previous one we made, in the cross product we made a determinant, right? And in that we had I, j, k with components of a and components of b. Here, since the answer, the total answer that you get from here is going to be a scalar, so you don't have to use I, j, k, right? So instead you will make a determinant, but it will be in the form of the components of a, components of b, and components of c. Okay, now it represents the volume of a parallelepiped formed by the three vectors a, b, and c. Okay, if the value is 0, it means that the three vectors are coplanar, that is, they lie in the same plane. All right, that means that you have, let's suppose you have a piece of paper and all those vectors are lying on the piece of paper, right? It means that they are on the same plane. It means that the value of this scalar triple product becomes 0. There is no three-dimensional thing happening. Okay, for a scalar triple product it has to be three-dimensional. All right, the sign, that is either positive or negative, shows that whether the three vectors are from a right-handed or a left-handed system. So if it's a positive answer, it's going to be right-handed. If it's a negative answer, it's going to be left-handed. Okay, now this is what you need to remember to solve questions related to scalar triple product, the properties. So according to the scalar triple product property, a dot b cross c, which is basically the scalar triple product, is also equal to, you can, in place of a, you can also write b, and then a goes inside, of course, so it's going to be b dot c cross a. Or if you take c outside, so it's going to be c dot a cross b. Okay, so a dot b cross c is either equal to b dot c cross a or c dot a cross b. Okay, you will be using this property to solve questions that are related to scalar triple product. Okay, changing the order of two vectors changes the sign of the result. If you change the order, for example, in place of b you have c and c, just replace b cross c becomes c cross b. So the sign changes. All right, so changing the order of these two will also change the sign of the resultant. Okay, so let's now move on towards solving one of the questions from CSS past papers for 2015 that came in Applied Mathematics examination. We have question 1a, which is exactly prove that a plus b dot b plus c cross c plus a is equal to 2 into a dot b cross c. Now when you look at this question that came to you, what do you understand? Basically, this thing here, a dot b cross c, that is the right hand side, is exactly the scalar triple product formula, right? So 2 into means 2 times of this thing, right, is equal to what? A plus b dot b plus c cross c plus a. Now how do you understand, what do you understand from this question? Basically, you can see if this is a, let's suppose, dot this is b cross this is c, so isn't this exactly similar to this a dot b cross c, right? Only difference is it has 2 here, and this 2 comes why? Because of this complexity that's happening, that is a plus b. Instead of a you have a plus b, instead of b you are having b plus c, and instead of c you have c plus a. Now you have to prove this identity, this thing you have to prove, that is 2 times of the scalar triple product is this thing over here. All right, so what we are going to do is we are going to take the left hand side first, that is the left hand side part. Let's expand the left hand side first. We take, let's suppose a plus b you can write it as u, b plus c you write it as v, and c plus a you write it as w, just to simplify things. Okay, so this means that in place of the first one you have u dot, you have v cross w, which is exactly this thing, okay, which was the left hand side. So first we solved this part, the thing inside the square brackets, that is b plus c cross c plus a. For this you have to use a distributive property. What is a distributive property? That is distributive property of cross product. We already saw this in the properties of the cross product video, so make sure you check that out. B plus c cross c plus a can be written as b with c, okay, and cross in the middle, plus c with c. So it will be, sorry, we're doing b, right? B cross c, okay, I'll just write it here. So first you will write b cross c and b cross a with plus in the middle because you have plus. Then you will have c cross c and c cross a, right? This is here. All right, that's what you get from the distributive property. All right, but now if you look at this part, you have c cross c here. This c cross c is obviously going to be 0. Why it's going to be 0? Because we know from the properties that if the vector are on the same line, right, the angle between them is 0, right? And since it's cross product, in cross product the formula has sine theta, and sine 0 will become 0. So c cross c will be equal to 0, right? Therefore, this part when it becomes 0, you are left with b cross c plus b cross a plus c cross a. All right. Now you take the dot product. So this part is now written as this, right? Substitute this part with this. This is what you're left with, right? Now you have to take the dot product. So what you're going to do is use the distributive property of the dot product. So in the dot product, you will take first you have a. So a with the next element plus a with the other element plus a with the last element, right? Because inside the square bracket you had 3 elements, right? You had b cross c plus b cross a plus c cross a. So a with first one, a with second one, then a with third one, plus next b with first one, b with second one, and b with the third one. Okay, now you're just going to simplify. Now you have to be careful here. How are you going to simplify this entire thing? A dot b cross c, b cross a, which you see here, this part, okay, when you do the dot, when you do the distributive property on this particular thing, right, what do you get? You get a dot b and you get a dot a. Okay, sorry, it's cross, so you get a cross a. Since a cross a is 0, so this entire thing becomes 0. Okay, Similarly, when you're talking about this, the next one, which is a dot c cross a, again a cross a is 0, so this entire thing becomes 0. Okay, then if you talk about this one, you have b dot b cross c, so b cross b is 0, so you get 0. Here also b cross b is 0, so you get this thing as 0. So basically this becomes 0, this becomes 0, this becomes 0, and this becomes 0. So the trick here is, if you have common elements, so this thing, if it exists inside, it will become 0. This thing, it exists inside, it becomes 0. Here also this thing exists inside, it becomes 0. This thing exists inside, it becomes 0. Here all three elements are different, so it's not going to become 0. Here also all three elements are different, so it's not going to become 0. These are two things left. Okay, so now we have these elements are becoming 0, so we are left with this and this. Okay, therefore we write it, we are left with a dot b cross c plus b dot c cross a. All right, but recall the cyclic scalar triple product identity where we had b dot c cross a. Remember the first slide where we said that b dot c cross a is equal to a dot b cross c. So we use that property which I told you, remember the property, which is b dot c cross a is equal to a dot b cross c, which is also equal to c dot a cross b, right? So you have that property here. Now replace this b dot c cross a with a dot b cross c. Hence you will have a dot b cross c, and you will have both two of these things, right? So a dot b cross c plus a dot b cross c is what you're going to get. Therefore, when they are 2, so you can write it as 2a dot b cross c, right? And this is what we were proving. So you have the left hand side, you use the left hand side, and you reach the right hand side. All right, that's how you're going to solve this question. Okay, so make sure you remember the properties, make sure you remember the formulas. You have to remember how c cross the same vector when they lie on when you have one vector and you are doing the cross product of that vector with itself. So in that case, it means that they are lying on the same plane. They're lying on the same line, right? Therefore, the angle between them is 0. So sine 0 is going to be 0. Therefore, the cross product becomes 0, right? The thing over here. All right. So that is how you're going to get 0, and then you're going to cancel out the 0 elements, and the remaining thing is your answer. Okay. So take the left hand side and reach the right hand side. All right. So that's all for this video. I hope you understood how to solve the question, and you can do more questions of similar type in the examination. If you have any questions, you can type them down in the comment box. And that's all for this video. Make sure to like, share, and subscribe to my channel, and stay tuned for future videos. Take care. Bye bye.